Hi YouTubers. Preparation of graphite twine, which is encased in this AA equivalent cylinder, size of a AA battery. And this has been run through a circuit at constant current, approximately 620 milliamps on a breadboard for a number of days. And now I put in a very small pinhole. I hope you can see it, because I'm going to be adding drops of selected ionic liquids, deep eutectic solvents. I know that this case does not react, does not change shape or dissolve in dimethylformamide. That's a solvent that will have an electrolyte in it, a conventional electrolyte, lithium tetrafluoroborate. But we'll be putting other electrolytes in DMF, methyl carbonate, etc. So we want to make sure that we have a small hole to allow any vapor to dissipate. Now, normally they run organic solvent-based supercaps. Rule of thumb, about 2.7 volts. It's quite arbitrarily based on industrial investigations of supercaps that are commercially available. I'm going to attempt to run them at about 4.7 volts, 250 milliamps. And I want to see the effect. Now, this is not an electrochemical cell. This is going to be run in a circuit with an LED. This is a rated 3-watt LED as electronic load. But I'm going to be running this in what I call a wet circuit. The wet circuit would have such a graphite material that has been soaked with an electrolytic solution of choice. The dry cell version, as I define it, would be what I just did here, running it for a number of days at a certain constant current without contact with any electrolytic solution. I want to see the effect of this, and I do suspect there will be changes in surface area which can be studied by the scanning electron microscope. I'll keep you posted on our results. If you reproduce such work, I recommend putting a breadboard in a fume hood, or I would use a printed circuit board. And I know I've read about breadboards being used at 5 volts, 1 amp. I wouldn't do that. If you're going to attempt that, I would make sure that's in a fume hood. So I'm not going to go above 250 milliamps. This is one running at 4.7 volts. I just would not take the chance, particularly if you have an older breadboard. For my purposes, this will be fine. I want to see in a week if the surface area changes, and that could be an indication that resistance is increasing. So there's a trade-off between the conductivity of your graphitic material and the resistance due to the surface area. You want both in a supercap electrode, conductivity and surface area. I'll keep you posted. Bye for now.